Right, in this lesson we are going to learn about differential equations. Before we start the lesson, let's understand the meaning. Okay, I have a question here on the screen which is called y equals to x cubed plus x squared plus x plus 1. What we do, we differentiate it first, right? Let's see what we get. Dy over dx is equals to 3x squared, right, plus 2x and plus 1. That's all. Actually, whatever we did now, this equation is called differential equation. So it's an equation in which there is dy over dx or f dash x, right? That's the meaning. Suppose we differentiated it again, right, for the second time. We get d square y over dx square is equals to 2 times 3, 6x and plus 2, right? That's also called a differential equation, nothing wrong, right? Now, what's the difference between those two means? This is called first order differential equation because that's dy over dx only. This is called second order differential equation. That's all we need to understand, okay? Second order differential equation. So that's the meaning. So it's an equation where there is x and y or only x and there is a dy over dx or even d square y over dx cube or d cube y over dx cube, blah, 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 right? So that's the meaning of the differential equations. What is our aim in this lesson means you will be given this as a question. Dy over dx is equals to 3x squared plus 2x plus 1. They will ask you to write this in the form of y is equals to blah, blah, blah. That's all. So that's what is called solving differential equations, right? So I will take you through one question. We understood the meaning of differential equations. Please just remember those words called first order and second order. All right, so I have a question here. Let's see how the examiners prepare these sums. We have a question called y equals to x squared minus 5x plus 6. Let's differentiate this. We have dy over dx is equals to 2x minus 5. That's what I have. So what the examiner is doing now is he says solve and he gives this to us. He gives this as a question and says solve. So that can be done. We transfer the dx to the right hand side. We keep the dy here on the left hand side. There is actually 1. Nothing means 1. So it's a 1 dy is equals to 2x minus 5 and dx is there. Then we integrate on both sides. Left hand side we integrate with respect to y. Right hand side we integrate with respect to x. So all x's must be here, all y's must be there because that's a dy, that's a dx. Now integrate 1 with respect to y, we get y, which is that, okay? Equals to, we integrate 2x minus 5, 2x squared divided by 2, therefore x squared, and minus 5x. And we always say plus c or plus k or m, some kind of letter which will denote this number. But we don't know what that number is, isn't it? Here. If this was a 1, your answer will, the dy over dx will still be this. If it's a 2, you still get the same answer. So we don't know what's the last number and therefore we'll write as a c. Now this particular equation that I got is called a general solution. General solution of the given differential equation. All right, watch these words please. Because we don't know that particular number, we call it as general solution. To find this number, you all know from C2, if I give you a point that lies on this curve, suppose, let's take a point, let's choose x as 1, so it's a 1 minus 5, minus 4 plus 6, 2, so y is a 2. So they will give you this information in the question, suppose. So if they give you that, what you can do, they said when x equals to 1, y equals to 2. This information is called initial condition. Initial condition. So remember those words, please. Initial condition. So when the initial condition is given to you, we can use this, substitute that in this equation and find the value of c. So y equals to a 2. Let's go a little bit back there. Y equals to 2, right? And equals to x is a 1. So it's 1 square minus 5 times a 1 and plus c. You get the value of c as 6, isn't it? So once you get 6, we put that value back here. Then we get the original curve. So once you find that value of c, you write the final answer as y is equals to x square minus 5x plus 6. The moment you write this particular equation or the answer that you got is called a particular solution. Particular solution, right? Very important keywords, please. Okay, so general solution is when you do not know the value of the c or m or k. The point that they give you or the information that they give you extra in the question when x equals to 1, y equals to 2, that is called initial condition. And when you substitute that into the question there, and if you get c equals to 6, put that back into the question, write the final answer, this is called a particular solution. Because if I change this number to something else, I get the c value something else here. So initial conditions change, all right? So when the initial condition changes, the value of c also changes, and you get another equation which is called y is equals to maybe x squared minus 5x plus 1, or maybe x squared minus 5x and plus 7. So the first two are same, the last one is not same. So all these are the U-shape graphs that you know because it's a x squared. So we call them as a family of curves. Watch the keyword there, family of curves. That's what we do in the next lesson. So just remember how to solve these simple differential equations. Right, now I'm going to take you through the meaning of family of curves. Okay, so I have a question here called y equals to x square. Let's differentiate this. Dy over dx is equals to 2x. And now I'm taking this as a question. Okay, so my question is here. They said solve dy over dx is equals to 2x. That's what they said to us, suppose. So we will solve that now normally. So this is a 1 dy over dx. Keep the 1 dy on the left hand side and transfer the dx to the right hand side. You have 2x dx. And then we integrate on both sides, left side with respect to y, right side with respect to x. So integration of 1, y is a y, equals to 2x squared divided by 2, we have x squared. But we don't know, there exists a number here, so we say plus c, right? When the actual curve is, when c is 0, the curve might look like this. You all know, it's a U-shaped curve, right? When c changes to 1, this curve will move one step up. When it's a 2, that goes up again, right? When it's a 3, that goes. When it's minus 1, maybe that comes down. So what you need to know, these are called a family of curves, right? That is the general solution because we don't know c. Initial condition, if they give me when x equals to 2, y equals to 4, if they say that to me, I substitute them here, I can find c. When I find the c, the answer that I get is called, we said that in the last one here, particular solution. That's what it means. So that's all differential equations are about. Don't expect only the x to be on that side. You can have y and x also. As we solve the sums, you will be able to understand. Okay, we understood the meaning of differential equation. You will see an equation, x and y or only x, fine, but there will be a dy over dx or f dash x in it, or maybe d square y over dx square. So we have first order and second order, and it goes on like that. So we will solve some basic sums first. Okay. Question number 1 is on the screen. That's dy over dx equals to x cubed. That's all we have, right? So no number in front means that's 1. So we keep the 1 dy on the left hand side and transfer the dx to the right hand side. So it's x cube and dx. That's all. Once we get that, we say integrate on both sides. Remember, we are doing only general solutions, please. Integration of 1 with respect to y is just a y. Equals to integration of x cube, it's x to the power 4 divided by 4, that we know, and say plus c. So that's the general solution of the given differential equation, right? Then we have question 2, a similar one. Dy over dx is given to me, is equals to 2x squared plus 5x minus 9. So that's 1. So we keep 1 dy on the left hand side, and inside the bracket 2x squared plus 5x minus 9, close the bracket, and dx. That's what we have. So now we need to integrate on both sides, please, right? So if we integrate 1 with respect to y, we have y equals to, that's a 2x cube divided by 3, that you know, plus this is going to be a 5x square divided by 2, and that's minus 9x and plus c. Okay, so that's the general equation of the question. So I'm going to move dx to the right hand side, keep the 1 there, that times x plus 1 becomes divide by x plus 1. Left hand side there is nothing, means it's 1 in the front there, so you have 1 dy. We copy that, that's it, we achieved our aim, dy dx, right? All x's must be on that side, all y's must be on this side. Integrate, integrate, done. Integration of 1 is y equals to 1 over x plus 1. You all know, right? Natural log x plus 1. And then plus c. That's it. This is the general solution of that. It doesn't have to be x and y only. It can be physics, right? See, ds over dt, right? Displacement over time is given as a function of time. So that's 1 ds. Let's keep the 1 ds on the left hand side is equals to t square minus t plus 5, and that's inside the bracket. The dt comes to the right hand side. Okay, once we have that step, we integrate on both sides. So integration of 1 with respect to, say, s is simply s, is equals to t square will become a t cube divided by 3, and minus, that should be a t square divided by 2, you all know, and that's plus 5 with respect to t is a 5t, and plus c. That's the most important thing, right? So that's the differential equation. Copy that question, please. dy over dx is equals to x over x squared plus 5. Already x's are on one side, so we are happy. We can take the dx to the right hand side and keep the dy there. The number in front is 1. So it's 1 dy is equals to x over x squared plus 5 and dx. That's all. Just transfer that and then integrate on both sides with respect to y, with respect to x. So that's y is equals to, now this is a guessing style of integration, please. Remember, we did that, right? If you take find, this is the function x, that should be f dash x. You differentiate this, you get 2x. If that's a 2 there, my answer will be natural log. We all have done those sums. Because we introduced a 2, we multiply by half. So the answer is now half natural log x square plus 5, right, and plus c. So that's how we leave the answer, first order differential equation, and this is the general solution of that. Happy? Right, just be careful, all those rules come back, as I said, right? Trigonometric substitutions and all those rules we need to know. Cosec square x and times dy over dx is equals to 1. So x is there, dx is here, transfer them to the right hand side. So we have 1 dy is equals to 1 divided by cosec square. That's times, isn't it? So cosec square x is there and dx stays in the numerator. We integrate now, isn't it, on both sides. So left hand side is a y is equals to 1 over cosec square is actually sine square x, isn't it? Sine square x dx. We know how to integrate sine square x, isn't it? We write it in terms of the double angles of cos. So that's actually minus half cos 2x. As I said, you got to know all these rules, please, right? Times dx there, and now we can integrate that bracket. So we get the answer as a half x and minus half and a 2. 2 comes down, reverse of the chain rule, right? So it's a quarter, and then integration of cos theta is simply sine theta and plus c. Okay, so as we said, trigonometric substitutions, all those various rules that we have learned come back in this. That's why we learn differential equations once we finish solving all types of integration. So that's the answer for that. This is the general solution, please. We have next question. Try this one, please. That's number 7 on the screen. Dy over dx plus cos theta or cos x equals to x squared. Looks very simple. Keep the dy over dx on the left hand side only first. Equals to x square minus cos x. In other words, we simply write all x terms on one side, all the y terms on the other side. Then we integrate on both sides. That's a 1. So we write this as 1 dy is equals to, that comes inside the bracket, x square minus cos x, and dx will be there. We achieved our aim. So simply integrate on both sides, please. That's all we do. Integration of 1 is a y is equals to, they are separate terms, so we can integrate them. X square is a 1/3 x cube, you all know, and minus integration of cos is sine, and plus say m or some kind of letter. General solution. Okay, first order differential equations, please. That's the next question. Question 8, please. Dy over dx minus ln, right? Just be careful how we do that. Keep the dy over dx, transfer this to the right hand side. So it's a 5 plus natural log 2x plus 1. That's what I have. Once I got that, I can move the dx to the right hand side. If you want to move the 5 to the left hand side, it's entirely up to you, right? So keep this as 1. So it's a 1 dy equals to 5 plus natural log 2x plus 1 in the bracket there. Then the whole thing, big bracket, and dx. We know how to integrate this now, right? So integration on both sides. Y equals to 5x, okay, and then we have plus integration of natural log something is 1 over the same thing, right? 2x plus 1. Then chain rule, we differentiate. Now, we differentiate that. We'll get a 2, right? So the 2, we divide by 2. So 2 comes at the bottom. Reverse of the chain rule. So plus c, and we can leave it like that, or maybe open this bracket. So you will have one more step. 1 over 4x plus 2 and c. Okay guys, so this is how you solve the first order differential equations. Solving in the sense, we simply wrote the general solution only. If they give us the initial condition, means they give you some value for y and some value for x, we can substitute them, we can find c. Substitute back into the sum, that's called particular solution. Is number 8, it's on the screen. Dy over dx times 2x plus 1 equals to 5. So that's a 1 we know, so it's 1 dy is equals to, let's transfer the 2x plus 1 to the right hand side. So it should be 5 divided by 2x plus 1. That's right, isn't it? And then we have a dx there. So we integrate on both sides now with respect to y and x. Then we have the answer there as, that's a y is equals to, that's a y there, which is equals to 5 over 2x plus 1. So let's write the 5 as a 5. That's times 1 like. So it's a 1 over 2x plus 1 is ln 2x plus 1. And we differentiate that. It's a 2. So we divide by 2. So that's what we got. And it's a plus c. Right? That's the general solution of the given differential equation. This one, question 9, fancy it, right? Dy over dx e to the minus 3x equals to 1. Let's see, keep the dy over dx first, or maybe dy 1 and transfer the dx there. It's 1 divided by e to the minus 3x, that's a times sign, and dx. Nice question. Take this to the top, that's the easier way to do. Dx is there and 1 dy is there. Then integrate on both sides with respect to y and x, please. So that's y is equals to e to the 3x is e to the 3x. Differentiate that, you get a 3, so divide by 3 because it's integration. Reverse of the chain rule. So it's 1/3 e to the power 3x and plus c. Next question, please. That's number 10. We have, up to now, we just have only x, x, x. We may have some questions based on x and y also, please. Already, x's are on one side. So let's write that as a 1. So it's 1 dy is equals to, this. Let's take this to the top. We don't need to waste much time. That's a minus a half if you take this to the numerator and it times dx. Then integration on both sides, done. Y is equals to integration of this, 2x plus 3 to the power minus half plus 1, which is a half, divide by minus half plus 1, a half there, and also times by, you differentiate this, right? You get a 2. Reverse of the chain rule. Done. So actually 2 cancelled. We got the answer as 2x plus 3 to the power half. That's it. Y equals to, and k. That's very, very important because this is the GS, general solution. And right, this time the question is now dy over d